Hello everyone, my name is Ionut Cernica and I'm presenting Hack the Hackers Leaking Data over SSL TLS. I'll have a short introduction about blind injections, what is a blind injection, then problems that may appear with blind injections, scenario and challenges when we are exploiting the blind injection, blind injection over SSL TLS, then the demo time with SQL map, the most used penetration testing tool for when it comes SQL injections. And conclusion. Who am I? I'm a security researcher for Future Networks 5G Lab, also PhD student at Department of Computer Science, Polytechnica Bucharest, CTF player, penetration tester, entrepreneur. Actually, this research was done at my PhD, and I tried to innovate based on this research. I tried to introduce a new layer of security for web applications, and this was one of the components of that layer. We ran out of funds, and we take a break from the project. And the former bug bounty hunter, I used to be involved in many bug bounty programs. Special thanks for pen test tools. They have the best online penetration testing platform. You should try it. They give you a gift 2-week trials. You have to visit their website. I thank them because they are financially supporting me for being in Vegas and have this presentation there. Blind injection. It's about when you are trying to interrogate the server for true and falses in order to take one byte at a time from the information you target. This is done by Boolean based. This technique is done through Boolean or time based. And the most cases where you will encounter this technique will be at SQL injection vulnerability. So you may heard about blind injection, blind SQL injection. The problem. We can distinguish the true and falses from the encrypted traffic just looking on the length of the responses. This is for the Boolean, and just looking at the delays between the packets, between the responses. And this is for time-based. Maybe it's not a problem, maybe it is. Let's see if this is the real problem. No, the real problem is something else. It's Belost. It's a new hacking technique, a passive one. It refers to blind injection leak over SSL TLS. It's a passive attack, as I already said. No interaction with the victim, with the hacker, or penetration tester, which is extracting data from the server. And this is because blind injection exploits are written in a predictable way. So how's that? We have the F, which is the method, char set, binary search. You will see in the next slide. Then we have the two types of output that we are taking from the encrypted traffic. The two types of output, one is true and the other one should be false. And the result, the N, which is the input to the method, to the function, is the leak. If you can suppose the method and the two types of output you can find, it's a feasible brute force, then you can find the leak by reversing the steps. It's very easy to do that. Known methods of exploiting with blind technique. So these are the methods which we should find when we are looking for blind injection over SSL TLS. The char set method, which you have the letters and the digits, and you are starting to take the first letter A in this case and interrogate the server. Is the first letter of the information A? And maybe he said false. Then you go to B, you go to C, till you have a true from the server, and the server will say, yes, this is the D letter from the information. The first letter of the information is D. Good job, go to the second one, and so on. So we can reverse. If you suppose that the hacker did this, the char set, and used A, B, C, D, 0, 1, 2, 3, or 0, 1, you'll have this. This is challenging. You'll see in the next slides. But this is the way how this work, because most of the hackers use this in their scripts. The binary search we can use also as a as a method for exploiting the blind technique. The binary search, which is an optimized way to extract data from the servers. The SQL map is doing this, and it's an improved way of the binary search because it's not on the old ASCII. He's starting with the printable characters, and he's starting with the letters. Then it has some changes on the its binary search. And we have a demo with the SQL map, and you'll see that it's very easy to reverse the steps. And bit shifting, again, it's not so common, but it's a method, a known method, and I encountered it in a tool which it was doing SQL injection. Challenges with the extraction methods. No challenges when we are dealing with optimization techniques like binary search or bit shifting, because we already know the code, how they are doing, and it's easy to reverse the steps. But we are having some challenges when it came about charset method, because here it was the biggest challenge. Okay, biggest challenge. Yes, it was the biggest challenge. It was because we don't know where are the letters. If the hacker started with the letters, then the digits, or his charset is his charset starts with digits, then the letters, and you should brute force their position by rotating the output and looking on the output, make a text recognition or something like this to see to extract the database. How you exploit this over SSL TLS, over this protocol, it's an important one. We have the length of the packets. We are using the length of the packets for Boolean based, and we are using the delays between the packets to find the true from the server when it comes the time based. In some cipher there is a padding involved, so we still exploit this problem because it would work if the block size is smaller than the difference between true and falses. So true and falses will be differentiated by a huge length. And as a disclaimer, is not a problem with SSL TLS protocol. The problem is in the way we are written the exploits to exploit this type of attack. Scenarios of exploiting, we have the penetration testing company, which is doing a penetration test, and our pen tester is extracting with SQL map the database from a vulnerable web application. And can be a huge problem because someone with the encrypted traffic from his company or the internet service provider, because this is the second scenario, can look at his traffic and reverse the steps and take the same database as the penetration tester did. This will be included, this scenario will be in our demo. You'll see later. Our internet service provider, which has all the traffic, and he can start digging for information, start digging for database where our script kiddies or even professional hackers or penetration testers are trying to exploit databases, and our internet service provider can take the same database. And the third one, maybe one more reason why large countries have a strategic interest to pass the traffic of another country to their infrastructure. Maybe could be a reason, I don't know. Over Tor, future work. I was thinking at Tor, but I don't have exit notes, but if you have exit notes, maybe it is challenging to see what happened there, and if a script kiddie or a penetration or a hacker, a professional one, will dump some database in the wild, and you should be aware of the cell padding. And if you are lucky enough that your true and falses are bigger than the cell size of the padding in Tor, then the block size, it's smaller than the difference between true and falses, then you are lucky and you can recuperate the information exactly like the hacker did. Tools and exploits database. We try to analyze some tools, we analyze some tools, we analyze some exploits from exploit databases, and with no exception we find that all those tools and all those scripts were supposed to exploit blind injections were written in an unsafe way, and there is a big impact on when they are trying to exploit. When they are trying to exploit, there is a big problem because someone can reverse the steps much more if they know with what tool was made that extraction. And now for the demo, we are using the SQL map. We try to contact the two main contributors from SQL map. We didn't have a reply for 2 months ago, and we are doing this demo because even I would hide from you that SQL map and I wouldn't say a word about SQL map. Most of you guys already think about SQL map, that it may have the same problem, this problem, and you can check it very, very easily. So let's start the demo. We have a penetration tester which already started his SQL map against a vulnerable web application. The SQL map will find the exploit, the vulnerability, and will confirm it. In the meantime, we have three parties. The man in the middle starts a TCP dump, and he will get the encrypted traffic. The SQL map, as you can see, already find the vulnerability, confirm it, and exploiting it. So he's dumping data from the vulnerable web app. Man in the middle, he's listening on the traffic. He's taking the traffic. He's dumping all the traffic, even if it's encrypted. We'll see in seconds that that traffic, it's all about server hello and then the encrypted packets. And from those encrypted traffic will dump some data like packet lengths. Now we are doing this. So I will open with Wireshark. You will see that there is an encrypted traffic. Okay. So here it is. Look, encrypted traffic, server, client, exchange, hello, and so on. Then we are trying to dump some data packet length to a CVS file. With that file, we are running a Python script to take the packet lengths from the vulnerable web app to the penetration tester, those packet lengths we are interested in. And from those packet lengths, we'll see what packet lengths are for true and what are for falses. And we'll have a file with false and trues, and we'll feed our local SQL map with the same false and trues. Right now, I'm creating on the man in the middle a database. Doesn't have any connection with the database that was exploited before in the vulnerable web app. You can create any database. It's a dummy one, like the other one, but let's suppose that is a real one. And now we are trying to start an SQL map. Man in the middle will start an SQL map on his local machine against his database, which is already vulnerable to SQL injection with a web app, through a web application on the local machine. And right away, before SQL map starts to exploit that database, the man in the middle will start feeding the SQL map with the same responses as the vulnerable web app feeds the pen tester. And you will see that the SQL map will have the same results as the pen tester. The SQL map from the man in the middle will have the same results as the SQL map from the pen tester. So right now we are having the application which responds with the same true and false as the vulnerable web responded to the penetration tester. And now we save the file. We have the responses, false and trues, and as you can see, the SQL map is extracting the same data as the SQL map from the penetration tester. Let's see till the end. So the message from the database was extracted too. So what happened? So what we did in the demo, the pen tester from a company A, exploit a vulnerable web application with SQL map. The man in the middle took the encrypted traffic through a TCP dump, and he did a passive attack. How he did this passive attack? So it was no interaction between the man in the middle and the other two parties, web application and the penetration tester, no interaction. So this can have a big impact, this problem I found. So he extracted the true enforcers from packet lengths, from the encrypted traffic. So it doesn't matter if it's encrypted or it's not encrypted, doesn't matter. He just took the packet lengths and feed his local SQL map with the same true enforcers to leak the data. Or you can reverse these steps and create a tool that do the same but much faster. I did this to see the impact, to understand the impact much in an easy way. So the result, it was that the man in the middle, as you can see in this picture, took the same information as the pen tester did with the vulnerable web app. So this can be very tricky because when you are using SQL map, you should consider this. You are extracting data from vulnerable web applications, and those extracted data, those dumped databases, can be extracted by anyone only with your encrypted traffic. And it's not. There are many cases where you can have problems like this char set method. So how can we fix this problem? For the char set method, it's an easy way to shuffle the order of the characters in the char set, and only your exploit knows the position of each character, and someone like the man in the middle will not know ever. And for the binary search, you should add some extra steps. Of course, it will have an impact on the optimization because binary search tries to optimize the process. You'll have extra steps, but it's safer for you to add those extra steps. Conclusion, so the way we are writing blind injection exploits should be written in such a way that no one can reverse the steps of the communication between the exploit and vulnerable application. When we want to optimize the blind injection attacks, we must consider inserting random steps for the optimization algorithms like binary search or bit shifting or any other type of optimization. And as a defensive tech, you can consider this. So as I said at my PhD, I tried to introduce a new layer of security for web applications. Okay, it's a threat hunting. It's a layer because it's post-exploitation. It's a threat hunting, like a threat hunting. And what I was trying to do was to find ways to confirm attacks without looking at the payload, so the payload complexity doesn't matter. We are looking for other things in the data, like in this case the packet lengths, and confirm an SQL injection, and so on. Maybe some attackers won't take this in consideration. They will need full optimization. They want to take the data as fast as possible. So maybe can be feasible as a defensive technique. Even those problems with blind injection will be known from today. Thank you. If you have questions, please ask me.